When a muscle contracts, it pulls on the tendon, which then pulls on the bone to cause movement. The purpose of this model is to mimic the human arm and exhibit the full range of motion required to grip an object with some degree of force. To achieve this, the model is made up of cardboard for support, straws for stability, and strings for control. The thumb was also set to be opposed to the fingers to attain grasp, which is why it is able to lift the cup.
What did you find to be the most challenging part of designing and building your model arm and hand? We found the most challenging part of designing and building the model arm was determining how we're going to make the hand move and how big we're going to make it. It took 2 attempts to finalize the model of our hand, and getting the thumb to move was a challenge since it was the hardest finger to add.
How would the design of your model arm and hand be different if it had to pick up an empty cup and flip it over instead of pick it up? Our model would have to have a wrist which would allow the hand to flex, extend, and tilt in the direction of choice to flip the empty cup over.
Why do we need so many muscles in our hands, wrists, and arms? The muscles of the arm and hand are specifically designed to meet the body's diverse needs of strength, speed, precision, while completing many complex daily tasks. The muscles of the upper arm are responsible for the flexion and extension of the forearm at the elbow joint. Most of the muscles but move the wrist, hand, and fingers are located in the forearm.
Explain how your model arm represents actual muscles in the human arm. Our model arm represents actual muscles in the human arm, the cardboard as the bone, the straws as the ligaments, and the strings as the tendons. What organ systems work together to move your arm, your wrist, and your fingers? The muscular, skeletal, and nervous system work together to create movement. The muscular system and skeletal system hold the shape of the hand.
So what are some factors that make design of a prosthetic limb for human use a difficult task? Well, there are so many joints, bones, and muscles in our limbs that have very specific movements and therefore varying functions. Reproducing that is very hard without a central nervous control system.
How have prosthetic limbs changed throughout history?
Well, thanks to new technologies and the improvement of materials, prosthetics have come a long way since the first known wooden toe. Centuries ago, amputation was the default treatment for any serious wound to the limb. The history of prosthetics has always been intertwined with the history of warfare and the soldiers that fight.
Nowadays, modern prosthetics include most human body parts. Metals such as titanium are replaced with pylon, making the prosthetic lightweight, and currently anyone is capable of using prosthetic limbs.